Hello aspirant. In the last module, we have seen the general considerations for analytical method development in a separate module. And also we have seen the considerations for the method development in each and every instrumentation specific modules also. Now we are going to see analytical method validation. Why we need to do the validation and what are the validation parameters generally considered in the analytical method development. Let us go and see the analytical method validation in detail in the upcoming slides. In the analytical method development module, we have seen the general considerations of analytical method development and how a method generally developed. And finally, we have arrived to a method which will be derived into a standard testing procedure. So in the method, we might have finalized particular chromatography conditions, particular column, particular mobile phase, mobile phase flow rate, etc. So many specifications, so many parameters have been particularly finalized in the specific method. Now, at the end of the method development, we will be deriving a standard testing procedure after verification of the particular method. So, what would be the standard testing procedure containing different topics? A standard testing procedure contains first the title of the method. For example, HPLC method of analysis for determination or quantification of paracetamol from Calpol tablets. Like that, the title will be there. Then the objective, you have to quantify particular drug, and the scope of the STP will be quantification of particular drug from a particular dosage form. Then the rationale is to why this particular STP is being used has to be given. Then the responsibilities will be the analyst and other people who is responsible to carry out the analysis. And the definition, if at all there is any definition, is need to be given, like validation, what is method validation, define method validation, certain kind of definition you can give. Then we have to start the procedures like the solution preparations, like standard solution, sample solution, reagents preparations, everything will be covering in the standard testing procedure. Then we have to give the instrument conditions, instrument details, and or chromatography condition like column specification, mobile flow rate, detector specifications, and the instrument specific details we have to give. Then the sample preparation procedure. What is sample here? Your tablet, Calpol tablet. So tablet, from the tablet you have to extract the particular drug, then you have to analyze the drug. So the sample, how you are going to extract, how you are going to separate, how you are going to prepare the sample for the analysis is important here. So the sample preparation will be given. Then how you are going to run the particular analysis sequence, that will be given. Like you are going to inject first the system suitability, then you are going to inject the standards, then you are going to inject the samples, followed by the bracketing standards. And like that, the sequence will be given, tentative sequence. Then any special precautions need to be taken during the method development or during the method of analysis will be also given, like light sensitivity, hygroscopy, etc. will be mentioned. Finally, you are going to give the calculation methods for the analysis. After the analysis, whatever the data you are getting, that how you are going to calculate, that you will be giving, including the documentation procedures, etc. So the forms, how you will document the things, that is also given. And finally the references and revision history of the STP will given. So you have developed a method now, and you have derived a standard testing procedure. So after this, generally we go for validation if at all it is required. During the development also, you have already done some kind of verification parameters, similar parameters what we do in the validation, but validation is a documented procedure completely and a GMP procedure. So why it is required, that we are going to see now. A analytical method validation is required to prove the method is accurate, precise, robust, stable, and can give consistent results. So this validation also prove these all parameters like accuracy, precision, robustness, stable, and consistency. All those things here it is proven. But in case of verification also we do the same thing, but here it is slightly different because the validation establishes documented evidence that the procedure adopted for a test is fit for the intended purpose in terms of quality, reliability, and consistency of the results. So you are making that particular method in a robust manner, you are documenting the particular matter. You are doing experiments, putting the results in the tabulations in the form of documentation and making it perfect. So that perfect documentation of a verification of a analytical method is called validation. In that way also you can consider, and this will be goes for the regulatory submissions, etc. So the regulatory agencies require the analysis of the samples need to be performed with a validated methods. So method verification is a process of confirming the method is working fine. Method validation is a process of documenting properly that method is working is fine. And this documentation will be used for the regulatory submissions. And always these validated methods are a good asset for the analytical laboratory. Now we are going to see when the analytical method validation is performed. So as I previously explained, we have developed a method and we have a tentative final method in the form of STP. That particular method has been finalized based on the verification of several parameters, and we have a completeness of the method now. So once the STP is prepared, then we need to see whether a validation is required or not. It depends on several factors. So if a method validation is required, then you will prepare a method validation protocol before performing a method validation for specific method. So the validation protocol will contain chromatographic conditions and the detailed method of analysis, whatever we have seen in the standard testing procedure, sample preparation, validation parameters details, and the each and every parameter will have a acceptance criteria. So once you fulfill the acceptance criteria, then only the validation parameter is passing, otherwise it is failing. So all these things will be covering in the particular protocol. So once the method is developed, verified, then STP is prepared or method of analysis is prepared, then you are going to do the validation if at all it is required or it is essential for certain requirements. Now we are going to see what are the topics we are going to cover in the method validation protocol in general. So it is not limited to, but these are the general topics like title, scope, then objective responsibility of each personnel, then the instrument details, whether it is HPLC, GCMS or any other instrument, then the chemicals and reagents, what you are going to use for the particular method and the validation, and then the working standards, other standard details will be there and the preparation procedures will be provided. Then the chromatographic conditions, if it is a chromatographic method, then the solution preparation, method of procedures to prepare the solutions, all those things will be given. Then you will give the each and every method validation parameter and how to perform this parameter, then the acceptance criteria you will be giving. Then finally, you will be giving the calculations for each and every parameter and the documentation procedures like archival, how will you file a error or the mistake or a deviation, etc. You are going to cover in this particular protocol, or otherwise the SOP with respect to these things will cover, you will give the SOP reference. Then finally, you are giving the references and revision history, the reference which include the STP what or the method of analysis what you have documented already. If there is a method development report, that also will be part of this particular reference. What are the method validation parameters as per the guidelines or as per the requirement in general? So first is the selectivity and specificity, then linearity and range, then accuracy or recovery, then precision or reproducibility, that includes system precision or system suitability, then the method precision, then the intermediate method precision, then limit of quantification, then limit of detection, then ruggedness, then robustness, then finally the stability experiments. So out of all these things in verification we used to do first few parameters up to this limit of detection we used to do generally, like the method should be specific or selective, then the linearity, the range will be established, accuracy we do, precision we do, and LOD, LOQ we generally establish during the verification process itself. But here in validation, we have to do in a documented proper way, and along with that additional parameters like ruggedness, robustness, and stability. If it is very critical for some other molecules, then we do during the development also, verification also, we do the stability. But generally we do a proper stability experiments during the method validation. So we are going to see each and every parameter, why we have to do, what exactly it is, how it is being done in the upcoming slides. First parameter is selectivity and specificity. Both are synonyms, but they are different terms. Specificity is the unequivocal response of the technique to be specific analyte present in the sample. So generally when you take a tablet for the analysis, it is containing, for example, paracetamol tablet means it will contain many things. It may contain excipients like polyvinyl pyrrolidine, it may contain lactose, it may contain sodium chloride or some other salts, some other things will be there in the particular matrix. But you are going to analyze only the paracetamol. So your method should be specific to paracetamol. When you do that method, you analyze the sample, the peak which you are going to see, that is belongs to paracetamol. So the paracetamol standard will give the peak at the RT of 3 minutes, means in the sample you will get a 3 minutes peak for the paracetamol. So the method should be specific and the peak should be specific. Selectivity can be applicable to a collective response to a group of analytes having similar chemical and physical characteristics. For example, you have multiple compounds in a particular matrix and your method should be selective when a similar kind of compounds are there. For example, rubber oligomers, you have different oligomers having similar kind of structure but slightly different. Or some other chemicals, you have similar impurities. Impurities will have minor changes in the structure or molecular weight. So this and all similarly having the structure and molecular, but your method able to selectively analyze that particular impurity or the particular oligomer, for example. So that selectivity, specificity, both are in terms of generally both are similar, but when it comes to the specificity, when compared to the placebo or any other XYZ present in the particular matrix, it should give the analyte response. And in case of selectivity, in case of multiple similar compounds, it has to selectively give your analyte response. Then the selectivity should not be affected by interfering species such as degradation products, impurities. That's what I explained earlier. So it should not be affected by interfering species such as degradation products, impurities, and other sample matrix components. The method should meet the criteria for selectivity and sensitivity in the presence of deliberately added interference and sample matrix. So this is what I have explained in the previous points also. For the spectrometry or chromatography analysis, the specificity or selectivity is nil or minimal interference of the blank, placebo, or impurity at the particular wavelength, absorbance, or peak area at the analyte retention time, respectively. So basically what we are seeing that in the spectrometry or chromatography, for the analyte response should not be interfered by placebo or other impurity, related impurity of the particular analyte. So it should give you a specific peak. The method should give you a specific peak for the particular analyte. So this is what we call it as selectivity and specificity. Now it comes to linearity and range. Linearity refers to the ability of the analytical method to produce results in direct proportion to the concentration range of the analyte in samples with the required concentration levels. For example, if you are having 20 microgram, 40 microgram, 60 microgram and 80 microgram, and you should have peak area for 20 microgram. For example, 1000 means 40 microgram you will have 2000, 60 microgram you will have 3000, and 80 microgram you will have 4000. So that is the linearity you should get proportionally in the particular method. For spectrometry analysis like UV and AAS, the linearity curve will be plotted using the different concentration of the standard versus the absorbance. The concentration shall be taken on the x-axis and absorption shall be used in the y-axis. This we will see in the next slide in a graphical manner. And in case of HPLC, LCMS, GCMS, etc., the linearity curve will be plotted using different concentration versus obtained peak area of the analyte. In case of UV and AAS absorbance, it will be in the y-axis. In case of chromatographic techniques, we will have the peak area in the y-axis. So then generally the linearity will be determined using the minimum 6 standard concentration ranges between the 50 to 150% of the expected concentration level. That is, always the expected concentration will be the 100%. So from 100% you can reduce up to 50% and you can increase up to 150% to see the linearity whether your method is giving proportional response with respect to the concentration. The linearity report will include slope of the line, linearity range, y-intercept, and the correlation coefficient data. So you will have the y is equal to mx plus c equation in which you have this slope and the intercept, then the correlation coefficient, which is very critical for the particular linearity. The correlation coefficient always should be or equal to 0.99 or more than that is preferable. Operating range is deduced from the calibration plot. So you will have a operating range of the particular method. For example, I have told you example of 10, 20, 30, 40 or 20, 40, 60, 80 microgram level you established. So your range is starting from some 5 microgram little less than the 20 microgram, that is the LOQ or LOD, from there into the highest concentration of 80 micrograms. So you establish the linearity there, so the working range of the method will be in that particular range, maybe from 5 to 80 or 5 to 90, something like that, microgram per ml. So this is how you will plot a linearity. So you got the response, instrument response in terms of peak area or the absorbance, whatever you consider here in the y-axis, and the concentration of the sample in the x-axis. And you will have, for example, 20 microgram, you will have a response 10, 40, 20, 60 microgram will have 30, and 80 microgram you will have 40, something like that. Then you accordingly you are plotting this linearity graph. From this straight line you will get the y is equal to mx plus c slope and intercept, from which you can find the unknown concentration by extrapolation. For example, you have a unknown sample which is giving the response of absorbance or the peak area, that you can plot here, that will give you your concentration of the unknown sample. You can, using this formula also you can calculate that, and your method correlation coefficient of the linearity will be always more than 0.99 is preferable. Now come to the accuracy of the method. What is accuracy of the method? So now, for example, as we have seen the earlier, we have taken 20 microgram and you inject that sample and get a response. So when you do back calculation of the particular sample, you should get the accuracy back into 100%. That means same 20 microgram you should get. So you know the sample will have 20 microgram. You injected that, and by using the developed method, by using the back calculation, you have to get the 20 microgram back. That is 100%. Your method is then 100% accurate. So that accuracy will be checked in a different way in this particular method validation. Accuracy is the value of analyte corresponds to the true value by using the given analytical method. So if you are going to give 20 microgram or 100 microgram, for example, and you are in after back calculation you are getting 99 microgram, means your accuracy will be 99%. And the accuracy is measured by spiking the known concentration of analyte standard in the sample matrix or placebo matrix and analyzing the sample using method being validated. So you will spike the sample, the known concentration, and after back calculation, you get how much is the concentration you are getting back. So that is called accuracy or recovery. The recovery of known spiked concentration of the analyte standard shall be calculated. So the accuracy shall be determined using minimum 3 concentration level covering the specified range. So the 3 concentration generally three replicates will be given. So three concentration 50%, 100% and 150% range, we will be evaluating this particular accuracy from the expected concentration. So the assay procedure will have the accuracy generally for a standard, for a direct chemical, you will have the range of 98% to 102% as acceptance criteria, or 97% to 103% based on the particular concentration of the compound. For the impurities, the accuracy can be extended between 70 to 130%, depends on the particular impurities. And the RSD should not exceed the relative standard deviation. The variation should not exceed the 30%. Here the RSD is 2% or 3% here in case of the assay procedure. And here we will have the accuracy in case of impurities will be plus or minus 30%. So the recovery will be calculated by obtained analytical results or recovered concentration into 100 divided by the true value, how much you spiked. Right? Now come to the parameter like precision or reproducibility. So you are doing this accuracy, for example, you are injecting 100 microgram and you are getting back 99 microgram. And how many times you are doing that? For example, 6 times, and out of 6 times, how many times you are getting 99% or 98%? How much variation you are getting? You may be getting from 96 to 102% you may be getting for 6 times. So what is the variation you are getting in that particular method when you do repeatedly? What is the reproducibility of the particular method? So that is being established through precision experiments. So the precision will be generally divided into three different things. One is the system precision, that is system suitability, method precision, then the intermediate method precision. We are going to see one by one. What is first is the system precision or system suitability. So generally, whenever you do a analysis, whenever you start the instrument for today, then you have to make sure that your system is working fine. So for that, you will generally do 6 injections of the particular standard for the analyte, and you see that all the standard is showing consistent response. For example, you are getting a peak area of 1000 for 100 microgram per ml is your standard. That 1000 should be all the 6 times it should be given similar response. The same 1000, close to 1000 you should get, and the RSD, the variation should be less than 2%. Then your system is working fine. So this is what called system suitability. This is being done for each and every analytical run. So here for spectrometry, you will see the absorbance, and in case of chromatography, you will see the peak area for the particular analysis for the system precision. In this slide, we are going to see graphically how the accuracy and precision are being defined or described. So here you can see the different concentration. This is LOQ concentration. This is LQC concentration, middle QC concentration, and higher QC concentration. I have told you different concentration, 50%, 100%, 150%, like that you can consider three different concentration here, and you can have the LOQ concentration. So now you are injecting 6 times the same sample and you are getting the response. The mean response is here, standard deviation is here, and variation percent CV is here. So here the accuracy is what you are getting from the true value. For example, your original nominal value is 5.3. Here you are getting 5.4. Here you are getting 4.8. Here you are getting 5.5. So the accuracy is varying, and how much it is varying out of 6 times, that is called your percent CV, that is called precision. So precision is calculated here. This is your accuracy, mean accuracy, and individual accuracy here. So the accuracy percentage finally calculated of the mean value, it will be 101.9%. You have taken the known concentration of 5.3 and you are getting the average of 5.4, that is 101% is your accuracy, and the precision will be 6%, 6.4%. Like that you have calculated for all the levels, and it should be meeting the acceptance criteria or not. That will be checked during the validation. So here you can see the different methods, how it can, what kind of situation you can be in when you do the accuracy and precision. So this is the bullseye where you can see 4 times you do the experiments, all the 4 times you are getting all 100%. You consider this yellow is the 100%, so it is all the values, 4 values is close to 100%. So it is more accurate and more precise. And in this here you can see it is maybe accurate close to 100%, but not precise because it is varying around the 100%. Maybe this is 98, this is 99, this may be 102, this may be 101, like that. So this one you can see neither it is accurate nor precise. It's totally out of the bullseye where it is not even close to the nominal value what you have put in. This is here also you can see this is also not accurate, not precise. Here you are getting precision, it is close to each other but not accurate. Here neither accurate, not precise. So hope this is clearly understood from this particular demonstration. So we have seen the precision. In that precision, we have seen the system precision or system suitability, how you do. Then now your method precision. So how the method precision you will be performed. So in the method precision will be performed in the 100% level. So you are going to inject the 100% level 6 times and see that how it is varying. Based on the standard relative standard deviation or percent CV, we will be calculating the precision that I already explained, and it should not be more than 2% for the assay procedures, or sometimes the RSD of the method precision parameter can be 95 to 105%, where you will have the 5% is the precision, depends on the particular analysis it will be defined. Now it comes to the intermediate method precision. In case of intermediate method precision, the precision will be performed today by one person and next day by another person, or it will be performed today HPLC number 1 and tomorrow it will be performed in HPLC number 2. And how altogether all the results, both precision as well as the intermediate precision, how much results it is giving, whether it is falling within the acceptance criteria or not. That is what we are going to see in the intermediate method precision. So all this method precision and intermediate precision will be reported in the method validation. Now coming to the limit of quantification and detection, LOD and LOQ. So it is very important parameter in a method. Limit of quantification is the minimum limit or a minimum concentration you can analyze by using the particular method, and acceptable. And quantification. Mean how much minimum you can quantify in that particular method. Then the limit of detection is the, you may get maybe getting a peak, but it is not quantifiable. Means the detection is happening. The detection of the compound is not happening, but it is neither it is quantifiable or it is not in the validated range or the concentration range, means it is detection. So how much concentration you can detect, how much concentration, minimum concentration you can quantify is called LOQ and LOD. So that will be established by the standard deviation of the all concentration response and slope of the linearity curve will be used. So LOQ generally 10 sigma by slope and LOD will be 3.3 sigma by slope. Sigma is nothing but the standard deviation of all concentration response. After determining the LOQ and LOD from the above calculation, the LOD LOQ concentration samples will be prepared to establish the acceptance criteria. So how you will now prove that you are perfectly working with the limit of quantification in a particular method? So you have calculated the LOQ from the previous slide, whatever we explained, and now you are going to perform an experiment that it is perfectly working. So limit of quantification, the lowest concentration of an analyte in a sample that can be quantified with the acceptable precision and accuracy under same method. That means for LOQ also you have to do the precision and accuracy. So 6 replicates of the LOQ samples will be injected. For that, accuracy and precision will be calculated. And the acceptance criteria for LOQ accuracy and the precision will be determined, and it will be specified in the method validation protocol. It will be generally plus or minus 10% for the accuracy, and the RSD, that is the precision, also should be not more than 10%. And also you will have an additional parameter like signal to noise ratio for the several methods like chromatography methods and gas chromatography, etc. It should be 10:1 to establish the LOQ. Now in this slide we are going to see what is limit of detection. Limit of detection is the lowest concentration of an analyte in a sample that can be detected and cannot be quantified, which we have explained in the earlier slides also. So the acceptance criteria will be the signal to noise ratio will be 3:1 to establish the LOD. And this particular plot is explaining how the LOD, LOQ is positioned in a particular linearity curve. So this is the response and concentration curve where you have the working range. So this is the working range which I already explained. The particular method will have the working range from the linearity will be calculated, and this is the LOD and LOQ concentration you can establish from this linearity curve, and you will have the ULOQ, upper limit of quantification, also from this curve. Robustness is another method validation parameter will be performed during the validations, and it is an analytical procedure to measure of its capacity to remain unaffected by small but deliberate variations in the procedural parameters. So what is the deliberate variations you can do in a procedural parameters or in your STP? So for example, it can be determined by executing 100% concentration level with the variations of different pH of the solution, slight variation in the pH of the solution, or slight variation in the composition of the mobile phase, slight variation, and sometimes the flow rate can be adjusted and see whether any changes in the response can be obtained, or you can see the extraction time of the sample processing procedure. So all these deliberate changes, whether it is giving any changes in the response and how much it is going to be acceptable in the particular, when you do the particular changes, how much the changes happen and whether it is in the acceptable limit or not. That's what you are going to see in the robustness. So this is one of the critical parameter when you do the validation, and it should be reported. So during you do the robustness parameter, what kind of changes you can do in a liquid chromatography or a gas chromatography is explained here. So as I already told, you can see the influence of minor variation in the pH of a mobile phase, or variations in the mobile phase composition, flow rate, temperature of the columns, different columns, slight variation in the column specifications you can see. And in case of gas chromatography, same thing, temperature of the column, flow rate of the gas, and also different types of column minor specification variation you can check in the robustness experiments. Another method validation parameter is generally performed in in a setup where you want to do the analysis at different places. That particular method you want to carry out in a different places. So ruggedness will be proven by analyzing the samples at a different analytical laboratory by different analyst and a different column. Maybe the same specification you have to use and different days. So different laboratory, different analysis, different column and different days. So the ruggedness of the method will be proved the method stability and reproducibility across different facilities, different people using that method. So it is one of the method parameter will be performed by the method precision. The method precision will be performed at different places by different analysts using different column with the same specification at different days. But what you will perform is the method precision during the ruggedness. That has to be in the acceptable limits. Finally, you are coming to the stability experiments during a method validation. And stability is one of the important and critical parameter which is essential for the method. So you have to check your analyte is very stable in the particular solution form, how long you can use the solution, if it is not stable, how to stabilize it. So all these things you are going to establish through the solution stability of the particular method. So the solution stability of the standard and sample shall be proven at different storage conditions like room temperature and refrigerator temperature, etc. Whereas the reagent solution stability will be proven at room temperature only at different time intervals like 24 hours, 48 hours, and 72 hours. So the standard solutions, what is the analyte? Analyte solution you will do in the refrigerator as well as the room temperature. So room temperature, how long you can keep, or in refrigeration, how long you can keep once you prepare the standard solution. That is a pure working standard solution. Now the reagent solution, for example, you are going to use a sodium hydroxide solution or some other reagent solution which is used for the particular method. So for that you do only at the room temperature because you are not going to store for longer period, and you can see at the room temperature whether it is stable for 24 hours, 48 hours, and 72 hours. So the standard solution stability will be proven for the primary stock solution, then the intermediate stock solution, then the system suitability solution. System suitability is the solution is the one you are going to use for the system precision. And the sample solution stability shall be proven at different concentration level based on the dilutions in the method. So the sample solution stability is nothing but you are making one spiked sample, you are spiking the standard in the particular matrix and seeing that the spiked concentration is still how long it is stable. For example, you spiked 100 microgram and after 24 hours and 48 hours you are seeing whether you are able to recover the same 100 microgram after 24 hours and 48 hours. So that is what you are going to see in the sample solution stability. Standard solution is pure working standard solutions. So now you have developed a method and you verified the method, then you prepared the standard testing procedure or a method of analysis, and you have done the method validation also. Now you have to conclude the method validation by using the report. So the results of the method validation parameters will be tabulated in the method validation report, and the results or meeting the acceptance criteria will be mentioned. And finally you say that the method is acceptable. And the method validation results, if not meeting the acceptance criteria, then the reason for the failure needs to be investigated. If the reasons are because of the man machine measurement, etc., then the particular method validation parameter may be repeated without any error, or if there is a repeated failure, you have to go back and redo the method development. The method validation results are not meeting the acceptance criteria because of the method and the or the sample matrix nature, then the method needs to be returned or modified before executing the validation. That's what I said in the earlier point also. If you are able to, or if you are bound to get repeated failures in several parameters or one or two parameters, you have to go back to the bench and redevelop the method and re-verify the method, and again you have to perform the complete validation. So this is how you are going to conclude the method validation for the particular analytical method. So aspirants, in this module we have seen how to perform a method validation for a developed analytical method after verification and preparing the standard testing procedure. So we have seen the method validation parameters, how it is going to be performed, what is the purpose, and what is the general acceptance criteria. Thank you.